Okay, so we're comparing our two careers. We're going to use this NPV calculation. We have our time periods across, including now 4 different time periods. We have our cash flows for being a medical doctor versus a sports star. And we're starting off with some kind of discount factor. First, let's turn this into a discount rate. And just so we can make sure we know how to do that calculation, remember the discount factor is equal to 1 over 1 plus the rate. Okay, so we want to find a corresponding rate, and rates will be more comparable to other factors, real market rates. They're akin to what is the return we're getting on this, and so we can compare it to other potential investments. Okay, so let's turn this. Our factor is 0.95. It's equal to 1 over 1 plus r. If I do some cross multiplying here, I'll get 1 plus r is equal to 1 over 0.95, or r is equal to 1 over 0.95 minus 1. Okay, if I bring my calculator over here, I can do 1 divided by 0.95 minus 1 is equal to about, wait, I did not do that right. 1 divided by 0.95 is equal, okay, minus 1. Yeah, 0.053. So my rate here is equal to 5.3%. Okay, so that's the my rate, my discount rate that I'm using. That's again, this is a marker of, what kinds of preferences, situation, opportunity costs, inflation, things like that I have going on. Okay, so now that we have that out of the way, we want to go back here. We want to see which career has the best NPV, okay? And so I'll put this in green here. We're going to run this NPV calculation for both potential, the two careers I'm comparing. So I want to find the NPV for being an MD first, okay? And that's going to be equal to my discount factor, 0.95. And here's a key point that I didn't mention before. Note this exponentiation of time. Okay, as time goes further, as we go further in time, we use time as a we exponentiate that discount factor by the time period. So that's going to potentially get bigger or smaller further out in time. Okay, so we use this time value here and we put it into our equation here. So remember, the exponent of anything raised to 0 is 1. So this kind of cancels out and becomes 1. So I take my discount factor, I raise it to point time, and then I look at the inflow. Okay, the inflow here for my first MD choice is minus 5. Okay, so that's time period 0. I add to that time period 1, 0.95. Now I'm at time period 1. I exponentiate that to the first power, which becomes itself, and I multiply that by the inflow, which is 1, plus 0.95 raised to the 2 times that inflow, which is 10, plus 0.95 raised to the third times that inflow, which is 12.